If a runny nose only lasts for a week, it's within normal limits. However, if it lasts longer than a week, it means your brain and other organs are receiving less oxygen for an extended period, leading to unpleasant consequences ranging from increased fatigue to headaches and sinusitis. Now let's show you what happens when you have a stuffy nose. Look, this is the nasal mucosa. It's lined with cells of different heights, and their nuclei are at different levels, like in a crowd of people with adults of varying heights and children. Among these cells are two types of defenders. Some build barricades while others actively drive out pathogens. The barricades against viruses and bacteria in the nasal cavity are mucus. It's produced by special goblet cells and glands in the form of branched tubes, and some mucus enters the nasal cavity directly through blood vessel walls. Part of the tear glands also drains here through the nasolacrimal duct. That's why your nose gets stuffy when you cry. The defenders that expel invaders are ciliated cells. Each of these cells has 2,300 cilia on its upper surface, making the mucous membrane resemble a carpeted floor. These cilia constantly make synchronized movements, like a coordinated team of rowers, whipping bacteria, viruses, and other small particles in the right direction. There's a smart approach here too. Cells at the nose's exit push pathogens outward with their cilia, while those deeper inside push them toward the nasopharynx. When these infectious agents reach the throat, a person either spits them out with saliva or swallows them, where they're neutralized by stomach acid. Now let's see how all these mechanisms work during a cold or allergy. Factors like hypothermia, excessively dry air, abundant dust, and polluted air essentially paralyze the cilia's work. This makes it easier for infectious agents to penetrate the mucous membrane and cause disease. When infection breaks through the defenses, classic inflammation develops in the nasal cavity. This is the body activating its defense mechanisms. Immune cells in the mucosa begin producing inflammatory molecules called cytokines. These cause blood vessels to dilate and the nasal mucosa to swell. The blood vessel walls become more permeable. More fluid seeps out of them. Glands start producing mucus more actively, resulting in a runny nose. One of the inflammatory molecules released during rhinitis is histamine, produced by special immune cells called basophils and mast cells. This causes an unpleasant itching in the nose, making a person want to sneeze. Simultaneously, special dendritic cells in the nasal cavity are activated. They devour pathogens, destroy them, display foreign proteins on their surface, and go to introduce them to lymphocytes. Thus, dendritic cells are scouts for the adaptive specific immune system. When foreign entities are recognized, T and B lymphocytes are activated. T lymphocytes produce new batches of inflammatory molecules, while B lymphocytes transform into plasma cells and synthesize antibodies. What does the sick person feel during this time? Since the nasal cavity is small and further reduced by mucosal swelling, mucus literally flows like water from a faucet. Essentially, it's water containing inflammatory molecules, antibodies, and remnants of pathogens and body cells. Depending on its components, mucus can be clear, yellow, or green, and either thin or very thick. Gradually, over about 7 days, your body will completely eliminate the pathogens and the runny nose will stop. However, if it doesn't, that's a matter for a specialist, because a prolonged runny nose is a sign of many health problems.
This content is for informational and educational purposes only. Consult with a doctor or healthcare professional before following any recommendations provided in this video. Tell us about your experience in the comments and subscribe to our channel.